So we're going to be looking at inverses with logarithms and exponential functions. So here is our little key that tells us how to change these and how they're related. So when you're looking at a log or a natural log, all it's basically saying is for a logarithm with a base e, what's the exponent, which is y. So it's e to the exponent of y is equal to x. So x is our result. And it would work the same way here. This is log base e of y equals x. So it depends on where your variable would be. But they're inverses of each other, and so that's what we want to find. So if you're given an exponential, well, we're going to take that exponential form and rewrite it. So the first thing to do, though, to find an inverse is you switch the letters, because that's all that's really happening is the x and the y's are just switching. And now we rewrite it. So if you notice e here goes here, so that's a 3 in this case, log base 3. And then the x goes here, and then you end up with 2y minus 4. So you just kind of go like in an outward spiral. So it's 3x and then that one, 3x and then that one. So log base 3 of x is equal to this. This is always your exponent, so it does go there. And then we just solve. So log base 3 of x plus 4 equals 2y divided by 2, divided by 2, divided by 2. And so we end up with y equals 1/2 log base 3 of x, and you could bring that and make a square root, plus 2. Now domains. So this is an exponential function. So we already know it looks just like this. There is no vertical shifting. So its domain is negative infinity, positive infinity, and its range is 0 to infinity because we don't have anything added to it. There is no vertical shifting. So now we know that this is our inverse of our function. We can call that now f of x. And we end up with this. And what's its domain? Well, all you have to do is give it its range. So now it's 0 to infinity. And its range is negative infinity to positive infinity. Remember, the x and y's just switched. So domain becomes range. Range becomes domain for our inverse. Okay, so now we just want to check their mirror images. So if we input it, make sure with this one you use a change of base formula. So log x over log 3, that'll give us log x base 3. And now if we graph it, we get this. So let's look at our symmetry line, which is y equals x. That's when they're equal to each other. So that's where it is our flip. And yeah, you can see they're perfectly symmetric all the way. And here we have a horizontal asymptote. So you can see it's greater than 0. And then for the other one, you can see now the domain is greater than 0. So the range is greater than 0 for the blue. Domain is greater than 0 for the red. All right, let's try another one. So again, we're just going to switch the letters. And then now we're going to work in backwards. So first thing we want to do is either bring that 2 in or divide it. And so what I'm going to do is divide it. And I'm going to rewrite it as a base e, like that, just so that we have our conversion. So we're using this one right here. And so you can see our base is the base. That is our exponent, and that is our result. So it's going to be e to this is equal to that. So e to the x over 2 is equal to y minus 1. And then we solve it. Plus 1, sorry. So we end up with y equals e to the x over 2 plus 1. And you can break those apart if you want, or leave them together. So now this is our inverse function. And so now we need our domain. So with logarithms, the domain is the inside, cannot be negative. So we know our x minus 1 must be greater than 0. It can't be 0 either. So x is greater than 0. Oh, not 0, 1. So we end up with 1 to infinity for our domain. So it's just shifted. And the range of these is negative infinity, positive infinity. Remember, we already know that from above. Our domain is negative infinity, positive infinity, so the range would be negative infinity to positive infinity for our logarithms. So now we can say our domain for this function is negative infinity to positive infinity, which makes sense. It's an exponential function. And the range is 1 to infinity, which also makes sense because it's been shifted up 1 unit. So there it is. And then we can check that now in our calculator. And there we have it. See, there's our first one, shifted up 1, and that one's shifted to the right one. So you can see it's 1 to infinity, Perfect. And then the red one is from 1 to infinity. All right, let's try another one just for fun. So let's first start with the domain. So that inside of our radical must be greater than or equal to 0. And so first we're going to start with the 0 and look at it that way. So 3 equals e to the 2x, right? And if we move it over, we end up with this. So we're already looking for when is our exponential less than the 3. Okay. So if we solve it, ln, so log of 3 equals 2x, divided by 2, divided by 2. So x is equal to the natural log of 3 over 2. So that's where it's going to end. All right, so plugging in the calculator, you can either look at this inequality or this one. I'm going to pick the first one. So my y value is 3 minus e to the 2x. Perfect. And so if I graph it, here we go, right here. And we want to know when is this bigger than or equal to 0. So you can see it's right here is when it's 0. Now let's verify our number. So if I hit trace ln of 3 divided by 2, you'll see it says 0. So that is perfect. So it is bigger than 0 from negative infinity to here, and it is less than 0 from here on out. So we want from negative infinity to that number. That is our domain. Negative infinity to the natural log of 3 over 2. So now what is the range? Well, we're going to be thinking about it. You're going to be plugging negative infinity here in here, and we're going to be plugging in natural log of 3. So it's going in that direction. So if you look at it graphically, I've got it plugged in now, and we hit graph. You can see that it's going from number here down to 0. That is our y values, right? So 0 is the smallest that we're going to get. So 0. Now what is the biggest? Well, that happens with the natural limit. So if we're going to do this analytically, we've got to look at it as x approaches negative infinity. See, the natural log of 3 over 2 is giving us that number. The negative infinity is going to give us the other one. So what is happening to this as we keep going through this? Not infinity, negative infinity. Well, if we look at it this way, this is a positive x value here, right? Our x is approaching negative infinity, which is going to make this negative. This will become a fraction, right? So if this is a fraction, that means it's going to be going off to 0. So we end up with square root of 3. And you can also just think about it that way as well. We already know the other one was 3, right, when we did this. So if that was 3, then you're going to end up with square root of 3. So like this. So if we do our little quick limit, remember you can use your calculator as a limit. So we're going to negative infinity. So if we go to our table, you can see it's 3. Well, if I were to plug 3 in here, that's my 3 minus e to the 2x. I'm going to end up with square root of 3 for the other one. So 1.73. Now if I check that, see it's the same answer. So it is square root of 3, from 0 to square root of 3. Okay, now let's find our inverse. So first we switch our letters. We'll square both sides. And then we'll subtract 3. Divide both sides by negative 1. So this becomes 3 minus x squared. Natural log. I'm going to just put the e to the 2y. So that would be 2y. And then divide by 2. So we end up with y equals 1/2 ln 3 minus x squared. And that is our inverse. And so our domain then now will be from 0 to radical 3. And our range will be from negative infinity to ln of 3 over 2. Okay, but what makes this one different is if you come up here, when we dealt with the previous two, we had a plain exponential and a plain logarithm. So we had that horizontal asymptote and that vertical asymptote where we're getting just greater than and just greater than. But here we're talking about a radical. And with radicals, it's greater than or equal to 0. So I'm missing something on these two answers. It's not just all parentheses. So we had greater than or equal to here, which means that ln of 3 over 2 is actually, let's erase this, it's a bracket. And that y value, which was 0 that corresponded to it, is also a bracket. And then if you come down here, that same situation would happen. Then that would become a bracket, and that would become a bracket. And we can test this very quickly in the calculator. So if I look at the first one, which is our x equals the square root of 3 e to the 2x, and I graph it, we get this. So if I hit trace, and I plug in my domain ending point, which is ln of 3 over 2, you see it gives me 0. Not undefined, but actually 0. Those two are included. And if I plug in the inverse, and I graph it, I end up with this graph, which is our mirror image. But again, if I plug in that 0, you see I'm getting the ln of 3 over 2 here. If you plug that in your calculator, you can verify that. Right there, ln of 3 over 2 is that. So these two actually get brackets, and these get brackets because this is a square root here. 3 minus e to the 2x. It is possible to get 0 here. It's possible for it to be equal. So you got to pay attention to these when you're doing them. Strictly e to the x, or sorry, an exponential or a logarithm, then we're good. But if we throw some other algebraic parts to it, it's possible for them to be equal.